Okay, first of all, we are going to solve the inverse Laplace of 1 over s plus 10 using completing the square. Okay, if completing the square, okay, first of all, let's say then using completing the square first. So you got 1 over s squared plus 10s. So this is plus 10s, so divide by 2, so it's s plus 5, and then you close the bracket. Okay, you expand back, you should get s squared plus 10s, and then this is plus 25. So you got extra 25, so we need to minus back 25. So this is if using completing the square. Make sure the coefficient for s squared is 1. If not, you need to factor out the make it become 1. Then open your bracket with s. The linear term plus 10 you divide by 2, so plus 5. Close the bracket, you square it, and then you try to expand back, you get s squared plus 10s plus 25. So extra 25, and then you need to minus 25 so that you get balance back, get back s squared plus 10s. Okay, this is a technique of completing the square. Okay, after that, then you can find the inverse Laplace of this one using the technique of completing the square of this one, 1 over s will be the inverse Laplace of again, so you notice this one you got s plus 5 squared. To make the function as a fs minus negative 5, okay, you know it because numerator is constant. It's constant, so we can straight away no need. Unless numerator you got s, then you need make it become s plus 5 and then minus 5. Okay, this one numerator is constant, so you no need to do anything. You can straight away s plus 5 squared minus 25. Okay, this one is equivalent to the function of fs minus negative 5. Where we know the inverse Laplace of fs minus a will be exponent at ft. So where in this case the a is actually negative 5. So you should get exponent negative 5t. Ft is actually the inverse Laplace of the fs. Fs means s plus 5, you make become s squared minus 25. Okay, so you got the inverse Laplace of 1 over s squared minus 25. Okay, this is 25 is 5 squared. Here it will make it times 5. You have to divide by 5. So that's why the answer is exponent negative 5t over 5. The inverse Laplace of 5 over s squared minus 25 will be hyperbolic sinh 5t. Okay, this is using technique of completing the square. Let's check, should be under exercise 4e, question 2d. Yeah. So exponent negative 5t over 5 hyperbolic sinh 5t. Okay, we can also solve it using partial fractions. Okay, see. Okay, now we solve it using partial fractions. You got 1 over s over s plus 10. Okay, so you have two linear terms, so you can break it become a over s plus b over s plus 10. Okay, cross cape multiplication, you got a times s plus 10 plus b times s. Okay, you have the same denominator, that's why I just compare the numerator. And then for linear term s plus 10, you can substitute s equal to negative 10. So that, okay, the a term becomes 0. When you substitute negative 10 plus 10, the a term becomes 0. Then you can, okay, you can calculate for b. So you get negative 10b. Okay, therefore b is negative 1 over 10. Okay, you got another linear term. Okay, okay, bs. Then you can substitute s equal to 0. So left side is a constant 1. So when s is 0, the b term is, okay, gone. You can calculate for a, which is 10a. Okay, therefore a is 1 over 10. Okay, 1 over 10. So 1 over s plus 10. You got 1 over 10. Factor out 1 over 10. So 1 over s. B is, okay, I factor out 1 over 10. So this is 1 over s plus 10. Hence, okay, the inverse Laplace of 1 over s plus 10. Okay, it'll be 1 over 10's inverse Laplace of 1 over s, factor out, minus 1 over s plus 10. Okay. So the inverse Laplace of 1 over s, you get the answer is 1. Okay, inverse Laplace of 1 over s plus 10, okay, exponent negative 10t. Okay, you see. So 1k form, okay, this is using completing the square, you get the answer in terms of sin k phi t. This one you get in terms of exponent negative 10t. Okay, let's check. Then later on we can 10 e f. Question 1a first. Okay, correct. Okay, this is the answer using partial fraction. This is answer using completing the square. Okay, unless, okay, you change sin phi t, okay, to exponential form, where you have exponent negative phi t over phi. Sin, okay, should be exponent, I think, phi t minus exponent negative phi t divide by 2. Then you got exponent, okay. Go on. So 1 over 10. Exponent negative phi t times exponent phi t, answer is 1. And then correct. So minus exponent negative 10t. So okay, first of all, when we solve using completing the square, we get this form of answer, exponent negative phi t over phi, okay, sin phi t. Hyperbolic sin phi t, when you convert it to the exponential form, Okay, sin phi t is exponent phi t minus exponent negative phi t divided by 2. Okay, so I factor out the constant 1 over 10. And then exponent negative phi t times exponent k phi t, you get exponent 0, which is 1. And then, okay, you have, okay, exponent negative phi t multiplied exponent negative phi t is exponent negative 10t. So you have here. So we get back the same form with partial fraction after you change the hyperbolic sinh phi t in terms of exponential form. Okay, so this one is same question. We have since we solve it using completing the squared partial fraction, and then we can also solve it using convolutions, okay, theorem. Okay, you have one. Okay, you got 1 over s plus 10. Okay, I can choose, okay, fs is 1 over s plus 10. Okay, this one you can break it 1 over s multiply 1 over s plus 10. Okay, and then, okay, normally I will choose the simplest k function as a gs. So fs is 1 over s plus 10. Ft is taking the inverse Laplace of 1 over s plus 10. You get exponent negative 10t. Okay, taking inverse Laplace of 1 over s, you get gt, which is 1. Okay, and then you have fu, change t to u, so exponent negative 10u. Okay, gt minus u. Okay, we don't have t constant, that's why still 1. Okay, and then by using convolution theorem, the inverse Laplace of 1 over s plus 10, okay, which is in the form of the product of the fsgs, fsgs, in the inverse Laplace of the product of fsgs is equal to 0, integrate 0 to t, fu gt minus u du. Okay, so plug in the fu is exponent negative 10u. Gt minus u, okay, in this case is 1. Then integrate exponent negative 10u respect to u. You got exponent negative 10u divided by negative 10. Okay, 0 to t. So plug in the upper limit into u, so you got exponent negative 10t minus, okay, the lower limit, which is when you plug in u by 0, you get, okay, exponent 0, which is 1. So again, we get 1 over 10, 1 minus exponent negative 10t. So using convolution theorem, you obtain the same answer as what you solve using partial fractions. In here, then we use this one. In the inverse Laplace of fs over s will be equal to the integral of f tau d tau. Okay, to solve the same equations here. Where is it? This one. Yeah. Convolution. This part. Okay, this is so-called transform of integral. Okay, means the inverse Laplace transform of Fs over S equal to the you want F tau d tau or F, okay, Fu du also can, just a variable. Okay, transform of integral is said that is actually from, okay, the table of Laplace transform. Where is it? Yeah, this one. The inverse Laplace of Fs over S will get the integral of F tau d tau from 0 to t. Okay, then okay, we are going to use this one to solve the same equation you have here. 1 over S plus 10. Okay, I can view it as okay. If we have this form, the inverse Laplace of Fs over S. So okay, 1 over S, okay, over S plus 10, you can view it as 1 over S plus 10, where 1 over S plus 10 is the Fs. So this is divided by S. Hence, okay, you can also solve, okay, this inverse Laplace, okay, transform using transform of integral. Beside you use, okay, let's now we use completing the square. Okay, we use completing the square, not this one. We use completing the square, okay, and then normally we'll solve it using partial fractions. Also, we can solve it using convolution theorem. And then this one we see it is also can be rewritten as Fs over S. Then you can also solve it using transform of integral. Okay, hence this one. So Fs, then you will get your Ft. So inverse Laplace of 1 over S plus 10, you'll get exponent negative 10 t. So if you want F tau or Fu, okay, just only variable. So this is tau. So is using transform of integral, this is equal to, you integrate 0 to t, F tau is exponent negative 10 tau d tau. Okay, you don't like tau, you can also change it to u. Okay, integral of 0 to t Fu du also can. Then you integrate exponent negative 10 tau d tau. You get negative 1 over 10. Exponent negative 10. Exponent negative 10 tau divide by, okay, divide by negative 10. Put up the limit from 0 to t. So it's exponent negative 10 t. When plug in 0, exponent 0 is 1. Then I change back. This is to 1 minus exponent negative 10 t. So tally back with the answer that we obtained using partial fractions convolution theorem. So this is so-called the transform of integral. So okay, to find the inverse Laplace transform, so it's either you can use completing the squared, partial fraction, convolution theorem, transform of integral, depend on which one that you prefer. Or if sometime you cannot solve it partial fraction, you have to use convolution theorem.